Hi, everyone, and thanks for taking some time to come with me. Just to give a bit of context here, I'm in my car because there is a power outage in my area. So I had to find a last minute a place where I could get some signal on my phone and tether to my laptop. Anyway, so thanks for joining me for It's Time to Up Your Test Game. My name is Xavier Gouchet. I'm the mobile RAM team lead at Datadog. If you want to reach out to me, you can use my Twitter handle here or Datadog's Twitter handle. Before we start with our topic, a quick word about what we do at Datadog in the real user monitoring team. Our goal is to give you tools to monitor your web and mobile applications from your user's perspective, giving you some tools to know what area of your application needs performance improvements, giving you error management and alerting information, enriching your customer support, and giving you also application analytics. Um, I'll come back to that at the end of the talk. And now let's get to business. The agenda for today, we're going to have first bits to talk about common testing pitfalls and also how to address them. Please note that when I'm talking about testing, I'm not only talking about unit testing or UI testing or integration testing. All those pitfalls can be applied to any kind of testing, automated testing that you're going to do. And then once we've done that, we're going to be talking about two advanced topics that I really like when I talk about testing, which are fuzzy testing and mutation testing. So let's get started with common testing pitfalls. The gist of it is that testing is hard. And this means that tests are hard to write and hard to maintain. Um, what this leads to is that you're going to have poor tests, sometimes because of laziness. It's just test. Why should we put too much effort in it? Let's just write it and be done with it. Or sometimes it's because they are not thought through. So you just write one test for the nominal case, and then what could go wrong? And sometimes it's because the tests lack intent. You're writing tests because you're told to, because you need to increase your coverage, but you don't really know what you should be testing exactly. So we're going to address that. The first and most important part of it is that you should write clean tests. We all know about those great architecture books. We all know about those, conferences and articles and tutorials about how to write clean code. And the thing is that tests are written in code. When you're writing tests for Android, you're usually using Kotlin or Java. This means that you can apply all your best practices there too. So for instance, usually when you're in a team, when you have a project, you're going to have a code style and naming conventions. Well, make sure that you spend some time to also define what the code style, what the code conventions should be for the tests. For instance, in our repository in Datadog, we do have a huge part on how we should write tests and how we should think about testing. This is the talk that you should have in your team to say, what are the best practices when writing tests? Of course, all your keeping simple and solid rules and all other acronyms apply when you're writing tests, of course. And because you're writing with Java or Kotlin, you can use all the patterns that you're used to. You can use generics, you can use inheritance, lambdas, anything that you do like when you're writing your production code, you can also use when writing tests. Also, one of the best practices that we do have when writing production code is to not have hard-coded values to avoid those magic strings and magic ints that can crop over. This is especially true in testing, but we'll come back to that a bit later. Also, you should keep in mind the goals of testing. If you're asked what is the goal of testing, what's the purpose of that, most people will answer that it's to verify that the code works. And yes, that's the first point. You need to know that what you're going to put in production do work. But it's not the only thing. When I'm thinking about tests, I usually think about it as a contract. A test is a contract that says, okay, I have my product brief. I know my feature should do that. And the tests are making it explicit. Test is saying, when I give you this input, I'm going to get this output. When I do this action, I'm going to have this effect. And so the more tests you have and the more explicit your contract is going to be. And that's a good thing. You want your contract to be as explicit as possible, because anything you don't explicitly say in a test is going to give some margin of error. It's going to leave some loopholes in the contract, and for each loophole, you're going to have a bug. Also, the goal of test is sometimes to guide the development. This is what's called test-driven development. If you don't already know about this, please do watch a video, read an article. There are thousands across the internet. TDD is a really good way to write tests. If you can remember just one thing about TDD, is that you want to watch your test fail. If you never see your test fail, you can't be sure that it's going to fail when you need it. That is, it's going to fail when there's going to be a bug. So watching your test fail is one of the most important part of TDD. And again, we're going to come back to that a bit later. Another goal for testing is to prevent regressions. This is why we do run the tests in the CI. This means that because you have this airtight contract, this airtight contract running in the CI, whenever you're going to change something, you're going to refactor a class, you're going to change the way things work low level, your tests are going to be there to make sure that you don't change the contract. And finally, it's helping you ease the maintenance of your code base. If you have a very large code base, having tests make sure that the code is decoupled, that it follows your best practices, and that it's testable. So once you've applied all these best practices, that you're doing your best with the test, you need to cover all your cases. You need to ask yourself, what should I test? So each test should have a single purpose. So if your test is testing more than one thing, then you can split it and make 2 tests instead. And to make sure that you understand what's the purpose of the test, you need to reflect that in the name. What's really nice if you're writing your test in Kotlin is that you can use spaces in your method names using backticks, which means that you can write plain English names for the test that are going to make sure that the name reflects the intent of your test. Usually we try to use a test name that reflects the structure of the test. A structure of a test is usually in 3 parts. You have the first part that is preparing the object in the test, the feature in the test. You're going to set up the states, prepare the data. Then you're going to have the action where you do something with your feature. And then you're going to have the verification. This is where you're going to have your asserts or verifies. And you're going to make sure that the output matches what you're expecting, or you're going to verify that a callback was called. Basically, you're going to verify the effect. Usually, it's in the form given X, when Y, then D, or you can have A performs B on C event. If you reflect this structure, this intent in the name, then it's going to be easier to read and easier to understand what's tested and what's not. So to understand what you want to test, basically you need to think of any way the code might break. To give you a rule of thumb, usually you're going to have at least 1 test for the nominal case. So that is, you're testing when everything is working correctly, there is no error, the input is perfect. You have at least 1 test for that. Then you're going to have at least 1 test to vary each of the inputs, and also test when the input is invalid. When you're going to have a negative integer, when you're going to have a null object, when you're going to have an empty string, and so on. And then you're going to have at least 1 test for each of your error states, whether it's the error states your system might be in before the action, or the error state where you can get after inaction. And finally, you're still going to have bugs, of course, because the code base are growing more and more complex every day. So you can't know every bug beforehand, but whenever you find a bug, whether it's in QA or whether it's in production, you need to make sure that you write a test for this bug to reproduce it before you fix it. So you write a test, you reproduce the bug, and then you fix it. And that way, you just added 1 line into the contract. Basically, it's the reason the end user license agreement that we all say we read entirely and we never read are growing larger and larger. It's because whenever there is a trial against the company because a user did something that wasn't in the contract, they're adding a line for this specific case to not have another trial like that. So that's it for the pitfalls that you can fall in and the advice that I hope will help you have better tests. And now we're going to dive into some advanced topics. The first one is fuzzy testing. This is something that I really like because real users and all names Alice and Bob. This is a response to the hard-coded values. Hard-coded values we know are very, very bad, but it's especially bad when you're talking about tests. Let's look at a quick example and think at what could go wrong here. We have a method that's called extract host that takes an email address and extract the host part of the email. So here we have a test method to say, yeah, I want to verify that the extract host work. So I have an email, I pass it into my my method, and I verify that the result is what I expect. And here I'm using a hard-coded value. And it doesn't matter that it's not constant, extracted in static values or whatever. It's still hard-coded values. The problem with this test is that you're going to only test one value every single time. So basically, you're not testing that you know how to extract any host from any email address. You're testing that you can extract this host from this email address. And adding a couple of more examples is not a solution because humans are bad at generating randomness. To give you an example of a while back, I was doing this kind of testing using hard-coded values. And at some point, all my IDs were 42. Don't know where this is. But anyway, at some point, I had a test that verified that the output of a method was the ID 42 because it was the object I did put in. Problem is that I had other objects in there that also had an ID 42. And basically, I got my 42, but not from the right place, meaning my test passed, it was green, but I had a bug and I didn't know it. So this is where fuzzy testing comes into place. The basic idea of it is that you're going to have random data generated at first in your errands part, the first part, and then you're going to perform some tests with this random data. And in the end, you're going to verify that the outputs or the callbacks or whatever side effects you're testing matches the test data that is random. So basically, using random test data, you're going to have a wider range overall of data tested. This means that when your the method you're testing is taking an email as a string, well, you have the whole range of every possible string that could be passed in tested. Meaning that you need to understand the boundaries of what are valid and invalid inputs. When you create a random string to pass into your method, you need to make sure that I need to build a valid email address, an invalid email address. Maybe I want to build some thing that cannot be mistaken to an email, a valid email address. And the RFC for email address is very, very hard to understand. There are lots of corner cases that people don't really know about. Also, when you're using random data as an input, you don't know what this input is, so you cannot make assumptions as to what the results are. So you need to write your test as generically as possible. This means that sometimes you need to reverse engineer the way you generate your random data. So in our case, in our sample, instead of generating a random email address, you're going to generate a random host, then create a random email address based on this host, and then you're going to pass that to your extract host method and make sure that the result matched the original random host. And overall, this helps you find edge cases. In one of our classes in Datadog, we do some work based on the HTTP status code that a request returns. And this is based on the way OKHTTP works when making network requests. And we had one test to test for when there is an error. So basically we test, yeah, the status quo is returning something between 400 and 499. And we expected it to be the same way all the time. And what we learned was that for some specific error codes, like 404, for instance, the exception that is thrown is not the same as for other errors. And so basically using random data, we could generate any random number between 400 and 499. And at some point it would go to 404 and we would get, oh, actually we need to treat this case particularly. So we needed to add a distinct catch in our try-catch block. So introducing the Elmer library, this is something that I worked on and I created like 4 or 5 years ago when I started to notice those issues with hard-coded values. The goal of this library is to help you create random data for your test. So for instance, here in my class, I can add this rule. This is a forge rule that is provided by the library. And then I can create a field in my class that is an int and as an int forgery annotation. And basically for every single test that I'm gonna run, this int value is gonna be different. It's gonna be random and I'm gonna be able to, every time I run the test, run it against a different integer value. And so overall, not in one test, but overall over time, I'm gonna run it every day in my CI, every time I do a new test run. And eventually I'm gonna find all the edge cases that this could have. So this library allows you to generate any kind of data, Booleans, of course, numeric values, strings. You can also generate collections, you can generate enums, and you can also adapt it to your use cases. For instance, you can keep the control over the generation of primitives, and you can also generate custom class instances. So if we go back to our int and we want to control the int range, we can actually add some parameters in the annotation to say, oh, I only want an int between 13 and 42. And if you have, for instance, a book class, a book object, you can create a class named book forgery factory, where you're going to say, okay, I have my forge object, which can generate primitives. And based on that, I can generate my own book object. So I can generate a book ID, a title, which is going to be an alphabetical string, or even use a regex to generate an email. And this will mean that it's going to generate a string that is going to match this regex exactly. And then in your test, you can add, you can configure your forge rule with your book factory, and then you can just use the forgery annotation to instantiate your book. And every time you run your tests, you're going to have a different book in your tests. But one part of having tests is that you want to have your test reproducible, because if a test fails, you need to make it fail exactly the same way to know why it failed and correct the bug that made it fail. This library allows you to do that because whenever a test is going to fail, you're going to have a message that looks like this, which is going to give you a seed, which is basically the number that is the seed to generate all the randomness that the library can do. Meaning that in your test, you can then add this parameter, and when you're gonna run your test, it's gonna run exactly the same way it did when it failed. So you can add your breakpoints, you can know exactly what value was generated, and so you can understand why it failed. So that's it for mutation testing, for fuzzy testing, sorry. And then going on mutation testing, this is to talk about the false assumption that coverage, the code coverage, the information that we have means that our code is tested. Here's an image to illustrate this situation. So this is a joke, of course, but the idea is that here I have 100% coverage on my tests, and so I'm confident that yeah, it works and my code is thoroughly tested. And as we can see, it's not. The problem is that code coverage only tells you which lines of code are visited, not which lines are tested. It's going to tell you, yeah, you run your test, and this test ran through this method, and we ran through this loop and through this if block, but it doesn't tell you that it tested. because it doesn't know if it is tested. So when you have a report that says you have 80% of code coverage, it doesn't mean that 80% of your code is tested. It simply means that at least 20% of your code is not tested. Just a side note here, we had this can be this false assumption can be very dangerous, because in a previous company we had some objective on the quarter to say, yeah, if by the end of the quarter you have 15% of test coverage, so we started from 0. If you have 15% of your test covered of your code covered by tests, you're gonna have a bonus. And so I had a colleague that wrote, basically through reflection, wrote some code to go through 20% of the code base, just calling methods randomly with random data, and not doing any verification or assertions. So we had the code coverage 20%, but we didn't test anything, and we had the bonus. So this can be dangerous. So mutation testing is here to answer the idea of you should watch your tests fail. The basic idea is that code has bugs and tests are code. So as we said, the tests are written in Java or Kotlin, which means that at some point your tests might have bugs. So how do you know that your tests have bugs? You could write tests for your tests, but that would be very, very time consuming. Instead, you have the mutation testing algorithm. Basic idea is that you're going to have some valid tests. You're going to introduce mutation in the production code. So you basically going to introduce some bugs. You're going to change some parts of the bytecode, and then you're going to run the test again. So mutation testing doesn't touch the test at all. It tests the production code. And then you're going to verify that the test failed when you change the production code. For that, we're using the PI test library. It's open source on GitHub. You can use it. It's a Java library, but there is this plugin that works very, very well with Android and Kotlin project. And so basically, you can add it to your Gradle file. And when you run the PI test task, you're going to have some result like this. So if you've looked at some coverage report, this should be familiar. The idea here is not to say that you didn't visited these lines. It's to say, so the red line here with the X factor greater than 0 and so on line, it means that mutations were added. So something was changed in this line of code and the test didn't catch it. What that means is that, for instance, it changed the X factor greater than 0 into an X factor less than 0. And in theory, it should fail. If all your tests covered your product design, it should fail. But if it didn't, it means that your test didn't catch that. So what kind of mutation could you have? You can change a greater than into a less than or equal. You can change an and into an or, and vice versa. If a method returns an object, it's going to return a null. If you have an increment, it's going to be turned into a decrement, and vice versa. And so on. So you have lots and lots of mutation that this library can do. And of course, you can write your own if you want. And basically, if you think about your test as an incident response team, your mutation testing is similar to running a drill emergency. So this means that you're going to have fake issues in your code, and you're going to make sure that your tests are going to be there to catch them when they arrive. So it's very useful, but not critical. One thing to know about mutation testing is that it can take a really long time to run if you do it on a large code base. So usually the way I do it is I run it only on the feature I'm currently developing, just to make sure that my tests are sufficient. So when I'm writing a feature, I'm gonna make sure that I'm satisfied with my test. And when I'm satisfied, I'm gonna do a mutation run, and I'm gonna do another, and I'm gonna do another. And then I'm going to look at the reports, and I'm going to look and say, oh, yeah, I forgot to test this specific case, so I'm going to add a test for that. Keep in mind that mutation testing won't find bugs in your code. It's going to reveal issues in your test. And also, it only stimulates atomic faults. So it's only going to change, change the sign of an operation. It's going to change a number. It's going to turn a 0 into a 1, basically. But you can also write your own mutations. So you can actually say, oh, when I see this sequence of bytecodes, I'm going to change it into this other sequence of bytecodes. So that's it for my the topics I wanted to talk with you today. Just a quick key takeaway, if you only remember one thing from this talk. The first thing is that you need to be as confident in the test you code as you are in the code you test. The purpose of tests is to increase your confidence in your product and say, yes, I'm confident that this can go into the hands of my user and it's going to work perfectly. And so you need to be confident in your test to make sure that they have your back and they're going to be making sure that your code works. So to be confident in your tests, first you need to remember that test is code, so you need to be as smart, as rigorous. You have to show all your best practices when you're writing tests. Then you need to vary your test input because your users are going to use inputs in your product that you'd never thought of. And lastly, you should make sure that your tests are actually testing something and are not just written to be there and to make your manager happy. If you want to look at our code base, our Android SDK is open sourced on GitHub. So feel free to go around there, look at the test folders. You're going to see a few tricks that I talked about today. And you can look at how we write test Datadog. Also, we have a free trial link. It's dtdg.co/droidCon. You can go there right now to have a free trial of the mobile RAM product. And there is also a prize to win. 1 in 10 attendees who register for a trial will win a Google Pixel 4. So that's it for me. I really hope this was helpful to you. And I was really glad to be talking with you and to have your attention. If you have any question, I think we do have some time for Q&A, and you can also reach out to me on my Twitter handle.
Well, thanks so much, Xavier. We're very happy to have you do this. I'm going to ask Uli to share her screen. We do have a couple questions come up. Of course, I think one of the most important questions that we did have that we're not showing on the screen was from a user asking why you're not wearing your seatbelt. He was very concerned about that. So
yeah, I am parked. The key is not even in the slot, and you know, I'm very safe. Don't worry.
Yeah. Excellent. All right. Well, let's let you get to the questions. Here we go.
Yeah. So first question is, do you need extra tests for testing random test data generators? Very good questions. Actually, if you go into the Elmer library, you're going to notice that every single thing that I put into this library is tested. And this is very difficult to test. Most of the time, I manage to find ways to make sure that the randomness is really random. The toughest one would be to test for Booleans. So how do you test that a Boolean is random? That's one of the difficult things. Random test data also sounds like potential flaky tests. Yes, indeed, but it's not a bad thing. Because if you have flaky tests, it means that your tests are not testing enough. So it either means that you don't understand enough of the boundaries of your input data, or it means that some cases are not handled by your production code. So having flaky tests is a really good thing, and I do really like that. Usually when I use random values, you have ways to repeat tests. In IntelliJ and in Android Studio, if you go into the configuration of your tests, you have a tab that says that helps you say how many times you should run the test. And there's one option that says you run the test until you find a failure. So if you're worried about flaky test, you can just run your test and do run until failure. And it's going to run 1,000 times. And at some point, it's going to run into the exact issue that's causing your flakiness. And then you're going to realize that, oh, indeed, there is this edge case that I didn't understand. The next question is, does Almir do parameter space exploration or shrinking of fading case like Python hypothesis or Haskell quick shake? Not yet. This is something that I really want to do. Right now, I do not do this in the Almir, but this is something that I'm looking into adding to the library. So either as a JUnit plugin or a rule on extension. And hopefully it's gonna be coming soon. But it's an open source project, so feel free to send a pull request if you want to help on this. Thank you all. Thank you for listening to me, and I hope you learned one or two tricks in there. Next question is, hello, real good talk. You talk about learning TDD. I'm having a hard time finding a good example or video, but using modern practices. Any advice here? Yeah, the thing with TDD is that it's often hard to get into at first because most of the tutorials are using very, very simple cases. The main thing to remember about TDD is that you want to watch your test fail. So basically, you need to write your test first, and sometimes just having the test you write not compile is an error in itself. So it's part of the process. And so you're going to say, you're just going to say, oh, I want to call this method. The method doesn't exist. This is a failure. So you go and you create the method, and then it compiles and it's a success. And then you keep going on. I think when I started doing TDD, the first couple of months, I had to force myself kind of to follow the process. So for those who don't know, the process of TDD is write a test that fails, make sure and write the minimum code that make the test go green, run the test, and then you have a fifth step, which is refactoring, commenting, cleaning up the code. And then it's a loop. So forcing myself to follow these rules for the first couple of months really helped me get this as a habit whenever I wanted to write new features. Also, getting into TDD is very, very much easier when you do it on new features, so code that doesn't exist. Doing TDD on code that already exists is going to be very painful because you're going to be struggling because the code is already there. Usually when I do that, I found that watching my test fail is something very, very important to me. And so sometimes I'm writing a test after I wrote the code. Usually when I'm, debugging a weird situation that's, very, very hard to reproduce. And then I'm going to write the test, and it's going to go green immediately. And then there's something in my brain that says, oh, something's off. It should have gone red. And so I'm going to undo my modification in my code, run the test, make sure it goes red, and then I'm going to reapply my modifications. The next question is, how do you name tests with complex inputs? For instance, 10, 12 different input variables. If you have that much input variables, it might mean that your test is maybe too complex. Usually you're going to want to have some way to distinguish those. One way to do that is that I'm going to create different test classes to split some of the differences. So in those 10, 12 different input variables, possibly some of those can be some that you're going to see in almost all the tests in the class. So you're going to say, okay, I'm going to have let's give a random example. I have a class that will behave differently if I'm a free or a paid user. And so this means that you can have like a free my class test and a paid my class test. And each of those, and that way you can divide the complexity of the number of inputs and delegate it to the names. I hope I answered this question. Next question is again about TDD. Do you create your architecture first and then start the TDD, or from the start? It depends a lot on the topic and the feature I'm writing. Most of the time, I'm going to do a quick architecture first, just to make sure, and talking with my coworkers, talking to know if the direction of the architecture is good. But then one of the key aspects of TDD is also that you don't write code that you are not going to need. Meaning that because you're writing the test first, you're going to say, okay, I'm writing an API. This is how my API is going to be called from another class. This is how my interface is going to be used. And this means that because you know how it want to be used, this is going to drive your implementation. But yeah, again, it depends on the situations. If it's really something completely new and from scratch, I'm going to do a bit of architecture first. But the architecture is always just a compass that guides you to what you want to achieve. It's not a strict map. So sometimes I leave myself the margin of error to adapt to the usage I'm going to discover while writing the tests. The next question is, with random test data, how many test runs do you have in CI to make sure edge cases pop? Usually on the CI, on a daily per commit basis, we do have 1 or 2 run per test at most, except for a few edge cases. For instance, in some cases, when I generate a random enum value, I'm going to say, oh, I know that I have 10 different enum values that could be generated, so I'm going to run it 20 times just to make sure that I might go through all of those. Usually I'm using, so the trick I talked about earlier, to say I want to run until I want to run the test until I hit a failure. I'm going to use that before submitting my PR, meaning that I do most of the test run locally. So yeah, but again, this can be increased, for instance, depending on how many tests you have and how long you allow your test to run in the CI. We could have the test run 20 times each, but then it would increase the global run in the CI by 20. And since we already have 20 minutes with all the tools that we have in CI, we have like 20 minutes to have a full check. Multiplying it by 20 is not something that we do want to do. But of course, if you're using JUnit 5, there is the repeatable tests annotation that can allow you to actually repeat a specific test a specific number of times. Next question is, in Android implemented tests, we can't do hello test name. It must be hello test name. Do you have any recommendation here, like given a 1b or with underscore? This falls into a preference kind of situations. Using underscore, I don't mind using underscore, especially for test name where you need to have them readable. This will be something that you'd have to discuss with the rest of your team, because potato. I do prefer using underscore in this specific particular case because it's easier to read as a phrase, as a sentence. But I'm not against using another coding convention. Last question, I think, and I think we're going to be out of time after that. Do you think if we write comprehensive unit tests, do we really need a functional test or integration test? Yes, you need. The thing is that unit tests are there to look at the every single component of your code working alone in a void abstract from everything else. This means that, for instance, when you're interacting with another interface, you're going to use mocks, meaning that if you don't do integration tests, your unit tests are going to say, yes, this class works perfectly with this mock. It doesn't tell you that this class works perfectly with this other implementation of the interface. So having integration tests, so putting two or more components together and make sure that they work properly is essential. And having functional tests is also essential. If there is a question that I sometimes get asked on this, is that if you only have time to do unit tests or functional tests, which one do you do? The answer is functional test, because you need to have the high level, the test that's closest to your user be executed first. But of course, you need to have all of those if you have the time to do those. We do have one last question. What can you do if your UI test fail on emulator but works on real phone? This is a tricky question. There could be a lot of different reasons why the test fail on an emulator and work on a real phone. In some cases, I had was that the emulator didn't have the Google APIs and Play services. So in some cases, that can be an issue. In some cases, it was because the geolocation was weird. There is no silver bullet for that question. It's very, very tricky. Usually, I'm going to try to reproduce this on an emulator where I can add a breakpoint and learn why it fails. But I think you're going to have to hit me with the actual issue. If you do have an actual issue that happens to you with this, hit me up on Twitter, and I will take time to look through it. But there's no silver bullet here. There can be many reasons why the emulator is not working the same way as a phone. So that's it. Thanks again, everyone, for listening. I hope you learned something. And I wish you all a very, very good afternoon or day, depending on where you are, and leave you in for the rest of the webinar.